So today we're going to work on a tutorial using AdamsView version 2024 to create the geometry of a left mechanism. So on the screen we have our database opened. So we have new model, existing model, and exit. We're going to create a new database for our model. So here we're going to click on new model. Click on new model. Send us to a new box where we have create new model, model name, gravity, unit, and a working directory. In the model name, we're going to type the name of our model, which is left mechanism. Left, let's go mechanism. We're going to maintain our gravity to Earth normal, negative global Y. Right here, we're going to change our unit to MKS. The working directory is where we want to save our model. So you come to the icon here, click on it. You search for where you want to save your model. To save into the Adams folder here. So Adams select folder. Now we can see that our working directory is going to be saved in the Adams folder. Then we click on OK. Now that we created our database for our model, we have our working grid open. Then we have all these two boxes that we're going to use to, all these two boxes are going to use to build our model. But before we start, we're going to adjust the working grid. So I go to settings, I look for working grid. Click on working grid, and then this new box open where we can adjust our working grid. We have our X component, Y component size and spacing. So we're going to change the size in the X direction to 20 meters instead of 750 millimeters. And the size also in Y, also in 20 meters. So I have 20 meters, 20 meters. And then our spacing, we're going to change our spacing to 0.5 meters for both X and Y. X and Y. Now that we change our size and spacing for both X and Y meters, we're going to make sure that our orientation is in the global XY. So we come to set orientation, the drop down menu, and then we select global XY and click on apply and OK. Now that our grid has been adjusted, we can zoom out so that we can see our working grid. Zoom out so that we can see our working grid. Okay, so now we have our working grid adjusted to a more suitable working space for our model. Our next step is to create the geometry of the lift mechanism. We're going to create the base of the mechanism. So come to the solid 2 box where I'm going to locate box. Selected box, we have new part. We're going to make sure that the length, the height, and the depth are all checked. Then we're going to enter the dimension for the length, dimension for the height, and dimension for the depth. Our dimension for the length is 12 meters. 12 meters. Our dimension for the height is 4 meters. Our dimension for the depth is 8 meters. Now just make sure that everything is checked like we have already. And then we go to the working grid. We go to the working grid. So on the working grid, we right click on the working grid to open the location event box. Location event box where we're going to type in the position of the box where we want to put the box. The first coordinate is the x-axis. Second is the y, which is going to be -4. And the last coordinate, which is the 0. I always make sure that it is relative to the origin. Relative to the origin. Now that you have typed in our location, we just click on apply. Then our box has been created here. Now we have our base created in the working grid. Our next step is to create the mount of our mechanism. So we go back to the solid 2 box, locate a box, click on the box. All the length and the height, the depth has already been checked. So we're going to assign the dimension of our mount. For the mount, the length is 3 meters. Our height is 3 meters. And then the depth is 3.5 meters. Everything has been checked already. So instead of going to the working grid to right click to locate or to open the location event, already have it open from our previous instruction that we did to create this box. So in the location event, we're going to type the location for our new mount. Location is 9 for our x, exit 0 for our y, and 2.25 for our z. Always make sure that it is relative to the origin. Then click on apply. Now you can see that our box has been created, which is the mount has been created. Our next step is to create the geometry for the shoulder for our mechanism, our lift mechanism. So I go to the solid toolbox again. By this time, allocate cylinder, which is this one. Our cylinder, report, make sure that the length and the radius are checked. Going to assign the dimension for the length, which is 10 meters. The radius is 1 meter. While we still have allocation event, toolbox here, we can enter the location where we want to put our new shoulder that we are creating or our new cylinder that we are creating. So for the cylinder, the location is 0.5 for the X direction, 1.5, 4. First, make sure it's relative to the origin, and then click on apply. Now, we've created our cylinder. So the first endpoint is this. First, we have the first endpoint. We're going to set the second endpoint. So we're going to click on the center of our mount that we created to create the second endpoint for the cylinder. Create the second endpoint for the cylinder. Now we can see our cylinder has been created. Our next step is to create the boom for our left mechanism. So we go back to the solid toolbox, click on cylinder again. The length and radius have already been checked. This time our dimension for our length is 30 meters. Our radius is 0.5. Sorry, 0.5 meters. Now we come to our location event. Type in our location where we want to put our boom. So the location is negative 1.5. Sorry, negative 4.5 and 1.5 for the Y and for Z. Make sure it's relative to origin, click on apply. So our first endpoint has been created for the boom. Then we have to create a second endpoint. So for the second endpoint, we click on the center of. Click on the center of the shoulder that the shoulder that we created previously. Yeah. Now we have our boom created, which is in the green color. Our boom has been created. Now we're going to create the last geometry, which is the bucket for our left mechanism. The bucket for our left mechanism. So for our bucket, we go back to the solid toolbox, click on box again. The length, height, and depth are being checked. So we assign them the dimensions. So the dimensions for our length is 4.5 meters. For the height, we have 3 meters. And then the depth is 4 meters. Depth 4 meters. Okay, so we come to our location event, which has already been opened. That location where we want to put our new we want to put our new bucket for the lift, which is going to be around somewhere here. So our location is for our x is minus 6.75, 1.5 for our y, and then 2 for x, for z, sorry. Then make sure it's relative to the origin, and we click on apply. Yep. So you can see our bucket has been created to the exact position that we want it to be. So now that we have all the geometries that we want, we're going to create the fillets for the mount and then the chamfer for our buckets. Oh, first we're going to apply a fillet to our mount, using the fillet 2. Okay, so we go to the future toolbox where we have fillet and edge, we have chamfer and edge, but we're going to use this fillet 2 to apply fillet to our mount that we created in the geometry. So I click on fillet 2. We have radius, we have end radius. Make sure that end radius is checked. So under radius, I'm going to enter 1.5 meter. And then our end radius, I'm going to enter 1.5 meter. So now if you assign the dimensions to our fillet, we're going to select the edges of the mount. The edges of the mount are shown as you can see like this. Select this edge, going to select that edge. Then after selecting both edges, I'm going to right click on my screen to create the fillet. Now, so you can see our fillet has been created for our mount. Our next job is to create a chamfer and then a hollow into our bucket, which we're going to use the chamfer 2 and then the hollow 2. So first, let's create our chamfer. You go to the feature toolbox, click on chamfer. Oh, click on chamfer again, and then we have the weight. We're going to assign the weight to our chamfer, which is 1.5 meters. Now that we've assigned the weight to our chamfer, we're going to go to your working grid on our model that we've created. We're going to locate the edges of our chamfer, the edges of our bucket, and then select the first edge, select the second edge, and then right click right click on the working grid to create our chamfer. So as we can see, our chamfer has been created. Now, the next thing we have to do is to create a hole or make a hollow in our bucket. So we go back to our feature tools. We have our hollow tool. Click on it. Make sure that inside is checked. Sign our thickness to be 0.25 meters. Then we come to our grader model. Select the top face of the bucket. Select top face of the bucket. Then you right click on the working grid. We can see that our hollow or our hole has been created in the bucket. To make it easier to see your model, not in wire meshes or not in wire frames, but in a solid, come to the right corner here. This icon, which is wireframe or shaded toggle for current view. Click on it, and we have our model in solid. So as we can see, we have been able to build the left mechanism, the geometry for the left mechanism, which we're going to use for our simulation in the next tutorial. Thank you.